And let's see. Let's go ahead and do the test review. I'm gonna give you the Pear Deck. I'm gonna give you the link right now. Sorry, I thought I copied it, but start a new session. All right, here's the link. Is that it? There it is again. A couple of them. Go ahead and link into that. Start doing the Pear Deck. I'm going to start taking roll. Actually, before I start taking roll, let's talk about the test review. I have on Delta Math, I have what I'm going to review today is converting from polar form to rectangular form and rectangular form to polar form. That's what I'm going to review in class. I'm not going to review any graphing, no graphing stuff, okay? You guys can do the graphing on your own. I have a practice graph on Delta Math right here. I have graph practicing here on Delta Math. Let's see here. It's right here. You guys can see it. Is it on the bottom? Wait a minute. Oh, polar coordinates. Oh, this one right here. The practice test. The practice test. This is optional. This is just graphing. This is just graphing. It's just graphing. That's it. I figured this is better for you to review just by doing it in class. Plot the polar coordinates 3, 0, radius of 3, and a angle of 0. So you just go like that, and that should do it. Okay. So anyway, that's how you're going to review for plotting. But for now, I'm going to have you guys do the Pear Deck converting from rectangular form to polar form and polar to rectangular form. So here we go. You guys in the Pear Deck right now? Look right here. Look, to go from polar form to rectangular form, this is the easier one in my opinion. To solve for x, you multiply the radius times cosine theta. To solve for y, you multiply the radius times sine theta. That's all you have to do. And use your unit circle. Use the unit circle to help you solve for this. I have my unit circle right here. Boom, ready for it, right? So have your unit circle. And there you go. Make sure, if you need that written down, right? X equals r times cosine of theta. Y equals r times the sine of theta. So have that written down. And we're going to go ahead and start the first problem right now. We're ready to rock and roll. Just take the radius and multiply it by the cosine of theta. And boom. Okay, so remember, this here is the radius. This here is my angle, theta, right? So 4 root 3 times cosine pi over 3 for x, 4 root 3 times sine pi over 3. Go ahead and solve that. I'll be checking your work. I'm taking roll. I'm going to see how fast I could get through the roll right now. You guys are solving that. I'm already getting responses. Very good. But I'm going to take roll as you guys are doing this. Here we go. See how fast I can get through roll. So be ready to call your name quickly, even though you're working on stuff. Be ready. Be ready to say here quickly. So if you're getting near your name, have your mic off and ready. Here we go. I'm going to try to go fast. Fast roll, the fastest I can ever do. Donnell.
Here.
Nishi.
Here.
Madison.
Here.
Kayla. John.
Here.
Alex Garcia.
Here.
Evan.
Here.
Matthew.
Here.
Brandon.
Here.
Bella.
Here.
Joshua,
Here.
Annika,
Here.
Eric, Gracie,
Here.
Carlos,
Here.
Jose,
Here.
Ethan, Natalia,
Here.
Jaylene,
Here.
Giovanna, Taylor,
Here.
Jay, Gianna,
Here.
Jacob,
Here.
Roberto,
Here.
Ariana.
Here.
All right.
Here.
A lot of people.
Jay's
A lot
here.
of people are absent, or you're just a little slow. You got to be quicker than that if you're here. You got to be quicker. I go fast, right? Isaac Aquino, Ishi Blanco, Kayla Bradley, Eric Jones, Ethan Ramos, Giovanna Ruiz, Jay Singh are all absent. Let's start all over again. Isaac Aquino,
I'm here.
Ishi,
I'm here.
Kayla,
Here.
Eric,
Here.
Ethan, Giovanna, Jay.
Here.
Okay. All right. So I have Ethan Ramos and Giovanna Ruiz absent. Now, Ethan Ramos. Ethan, are you there? Giovanna, are you there? No. Ethan and Giovanna are absent. Okay, I'm checking your answers. Let's take it. Let's present as you guys are doing this. Okay, what do you guys get? Okay, now I'm presenting to everyone. Come on. There we go. Okay. X2, got to put it in coordinate form, but we got 2 root 3, 12. I don't know. Is that right? We have parentheses there. 2 root 3, 6. Another 2 root 3, 6. Another 2 root 3, 6. Another 2 root 3, 6. 2 root 3, 6. Yes, write it like this. I love it. This is how I want you to get it. This is how I got to write the answers in Delta Math. If I give the test in Delta Math, I think I might. 2 root 3, 6. 2 root 3, 6. Put it in comma form. I don't know, in the polar form. That's not polar form. This is polar form. 2 root 3, 6. And that is the answer. 2 root 3, 6. 2 root. That is the answer. Yes, Lucas. Yes. Do you guys want to see what Lucas looks like? I don't even know. I feel like I should show you what he looks like before the end of the semester. I don't know if you guys care or not. Okay. So 4 root 3 pi over 3. I'll show you how we get this answer. 4 root 3 comma pi over 3. Okay. Remember, this is my radius. This is my theta. Boom. Okay, so remember, x is equal to r cosine theta. X is equal to 4 root 3 cosine pi over 3. Now, take your unit circle to find out what the cosine of pi over 3 is. Remember, x is cosine, y is sine. So cosine pi over 3, this is the cosine. Pi over 3 is 1/2. So just say 4 root 3 times 1/2. So it's 4 root 3 over 2. 4 divided by 2 is 2 root 3. There's my x coordinate. Let's solve for the y coordinate. Y equals r times sine theta. Y equals 4 root 3 times sine pi over 3. So let's find the sine pi over 3. We look at the pi over 3. The sine is y, root 3 over 2. Root 3 over 2 is my sine. So I say 4 root 3 times root 3 over 2. So let's multiply it. Root 3 times root 3 is 3. So it's 4 times 3 over 2, or 12 over 2, which is 6. So that's my y. And coordinate form, of course, is 2 root 3 comma 6. And that's your answer. X comma y, or I comma r. I comma r. Let's do another one, shall we? 2 root 3 6. There's your answer. Okay, let's go with 7 or 6 root 2 7 pi over 4. Go ahead and solve for that one. 6 root 2 7 pi over 4. Go for it. 6 root 2. You guys are on there. You should be on your Pear Deck looking at it. Gosh darn it, Lucas. Come on, man. I don't think they want to see you, man. You're just like, I think you freak them out. That's what I think. I don't care what you look like. I wouldn't care. Who cares? Hey, dude, stop throwing an attitude. Oh my gosh, freaking. Oh. Ariana, thanks for sending the link to everyone, Ariana. Okay. All right, let's see what you guys got. Anyone need more time? Let me check your answers out. Oh, pretty. Oh, looks good. Okay. Okay, so let's take a look at our answers. Okay, 6, -6. 6, -6. Ooh, look at all the work. Beautiful. Love it. Yes, 6, -6. That's exactly right. Oh my gosh. Oh, so pretty. Oh, so pretty. How do you do that? 6 negatives. Either that or it has some sort of disease, illness. 6, -6. 6, -6. 6, -6. Very good. Very good. Very good. Very good. Nice. Feel like I should show you guys how to do this. Should I? Oh, freaking Lucas, get out of there. Oh my, oh, jeez. He wasn't supposed to do that. Lucas. Oh my gosh. Oh my gosh. Feel like I should have, oh. Ah. He just did it on his own. I'm sorry you guys had to see that. I know you guys didn't really care. Oh my gosh. Well, okay, let's do a proper introduction. Okay, this is Lucas. All right. What he is he's like, he's actually a monkey that you could shoot around with his arms. Oh, shoot. I just broke Lucas's, oh, Lucas. Oh, his arm just fell off. Oh my gosh. Oh, oh my gosh. Poor Lucas. Are you okay? Lucas, I better do monkey CPR. Okay. 1, 2, 3, 4, 5. Breathe. Breathe, Lucas. Breathe. 1, 2, 3, 4, 5. Breathe. Breathe. Lucas, get away. Oh, oh my gosh. He's dying. He's dying. Oh, Lucas. CPR. 1, 2, 3, 4. Lucas. No, Lucas. Are you okay? I'm trying to do monkey CPR. That sounds very inappropriate, though. Sounds so inappropriate. Lucas. Lucas, are you okay? 1, 2, 3, 4. Lucas. Do you guys remember how to do CPR? I can't even remember how to do it. Breathe. 1, 2, 3, 4, 5. Breathe, Lucas. Lucas, are you? Oh, Lucas, Lucas, here. 1, 2, 3. Your arm is missing. He has no arms. Oh my gosh, the monkey has no arms. Ah, Lucas. 1, 2, 3, 4, 5. Breathe, breathe. Okay, shock him. I think I have some. Do you have anything to shock him with? I'll use my cell phone. Oh my gosh. Ah. Okay, I think he's okay. Oh, Lucas. Oh my gosh. Can a monkey die if his arms are off? I don't even know. Okay, wait. I'm supposed to be teaching math right now. I don't even know what came over me. Does anyone need me to do this? 6√2 pi over 4 x equals, see, I'm all flustered because Lucas just had a Lucas trauma. Cosine 7 pi over 4. Look on your unit circle. 7 pi over 4. Oh my gosh, I don't know if I can work right now. Cosine is √2 over 2. Am I going too fast? 6√2 times √2 over 2. √2 times √2 is 2. 6 times 2 is 12. Over 2 is 6. Oh, Lucas. Lucas. Oh my gosh. Poor Lucas. Actually, he seems okay. What's up, Lucas? Are you okay, Lucas? Oh, see, I can hang him. He has a little hanging thing. Anyway, whatever. Let's do y equals 6√2 sine 7 pi over 4. 7 pi over 4 sine. I'm going very fast. Look, it's negative √2 over 2. That's the y. The sine is the y. So it's going to 6√2 times negative root 2 over 2. It's going to be the same as this one, except it's going to be y equals negative 6. Proper, right? 6, negative 6. That's all you got to do. Okay, that's the easier one. The easiest one, I think, in my opinion, is the graphing. Sorry, are there any questions? I'm going fast. I'm going fast. Okay. Okay. All right, let's do the next one. Bum, 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 bum. Okay, there you go. 6, negative 6. You guys got that? So next, converting from rectangular to polar form. Rectangular form to polar form. Rectangular to polar. Okay, like, you guys want to do this on your own? Can you guys see it? Am I presenting? You guys, well, you guys can see it on your Pear Deck, but I'll just put it on here too. I'm not sure what your guys' vision is like over there, but here we go. So rectangular to polar, we have negative 3 root 3 and 3 root 3. Now, this is more difficult, in my opinion. So I'll get you started. If you got it, you keep going. But in my opinion, I think the best thing to do, in fact, the best thing, let's not say it's a fact. We'll say facts. The fact is, not my opinion, the best thing to do would be to draw a picture.
It's root 2, not root 3.
Oh, shoot. Oh, I hate this job. Gosh darn it. How do I teach? Is it root 2? Negative 3 root 2, 3. See, that would have been a big mess. Negative 3 root 2 and 3 root 2. Oh, actually, root 3 would have worked too. But negative 3 root 2, comma 3 root 2. Okay. Negative 3 root 2, comma 3 root 2. So, we got to draw a general picture of where negative 3 root 2, 3 root 2 would be. Now, it'd be probably right about here. Go negative 3 root 2, you know, I'm not going to draw an exact graph. I'm just going to kind of draw it over there. But it'd be in this quadrant, right? X is negative, Y is positive. It would be here. Now, we are going to use our calculator to solve this, but our calculator will only be able to solve this angle right here. If I plug it in, well, we're only capable, because this is where the triangle is, right? If I was to draw a triangle, we know when you use tangent to solve for the angle in a triangle, well, the triangle is going to be right here. And our calculator is only able to solve with where the triangle is, right? Opposite over adjacent. It only solve for this angle. But that's not the angle that we want. We want this angle right here, right? That's the angle that we want, that big angle right there. We don't want theta, but theta is going to help us find it. And how's it going to help us find it is what it's going to do is we're going to take the bigger angle all the way across, which we know what this is, all the way around. That's the big angle. And if we take away theta from that, we'll get the purple angle there, right? Okay, so let's find theta. Or we also have to solve for the radius, right? So we're going for, from x, y, we want to solve for the r, comma, theta. So since I went on theta, let's do theta first. Okay, I'm going to draw a bigger triangle here. Just for presentation's sake. You guys don't need the bigger triangle. I'm going to go, actually, I'm going to check to see if you guys have answers. Let's take a look. I'm going to start drawing the triangle, though. So there's theta. There's 3 root. This is actually negative 3 root 2. Whoops, there you go. And here is 3 root 2. Solve for theta. Made it a little bit bigger. And I'm going to check out see what you guys got. E-I-E-I-O. With the blah blah here, the blah blah there, the blah there, with the do ra-ta-ta-ta-ta, ra-ta-ta-ta-ta-ta, ra-ta-ta-ta-ta, ra-ti-ti-do-do-do-do-do. Oh, okay. Actually, this is correct. However, our answer is going to need to be in radians. So we got to convert that to radians. Ooh, nice. That's correct. 6, 3 pi over 4. Ooh, that's a pretty design. Need the 6 there, but got 3 pi over 4, 6, 3 pi over 4. You guys are on it. Not many people have answered it yet, but. Let me show you what I've been looking at. Okay, so this is correct. The 135, you got to change it into radians. Okay, so, and by the way, whoever did this, look on your unit circle and you can find the 135 and you can convert it to radians. 3 pi over 4, 3 pi over 4, 6 comma 3 pi over 4, 6 comma 3 pi. Very good, very good, very good, very good, and very good. Well, there's even more. R6, good, you got the radius. 3 pi. Look at that. That pi looks like a freaking ninja pi. That's what I'm talking about. 3 pi over 4, 3 pi over something, 4, boom. Okay. All right, let's go ahead and I'm going to go ahead and solve this. All right. All right. Let me get my pen here. Oh, what the? Oh, that's gosh, that's gross. That's a monkey arm. Oh, get out of there. Oh, yuck. Yeah. Oh, get back. Oh my gosh. That is just terrible. Freaking, oh. Jeez. Oh my God. I'm sorry you had to see that. I'm gonna have to edit this out because this is supposed to be a rated G program that you're watching right now. So I'm sorry you guys have to see. It's hard for me to get like when the live stuff's here and I can't help the live stuff that happens, and that just happened. I'll just edit it out when I post it on the canvas that you just saw. Monkey morbidity. That sounds inappropriate too. I might have to cut that out too. Okay, let's go ahead and solve for the angle theta. Now, SOHCAHTOA means I have this opposite and adjacent, so I can use tan. So it's going to be tan theta equals opposite 3 root 3 over negative 3 root 3. Okay, now I'm going to change this because what the heck, this is diarrhea. I don't like working with diarrhea. Let's give it some Pepto-Bismol and change 3 root 3 over negative 3 root 3. Pepto-Bismol, this diarrhea.
It's root 2.
What's rude?
It's 3 root 2, I think.
Oh
yeah.
my gosh. I thought you said I was being rude
Not
talking
3
about
root
diarrhea.
3.
I don't know why I keep doing that. 3 root 2. Thank you. But anyway, thank you so much, Jay. So 3 root 2 divided by negative 3 root 2. Simplify it, and that's equal to -1, right? 3 root 2 divided by 3 root 2 is 1. It's -1. Okay. Now, to solve this, you guys, we're solving for theta here. We want to get theta by itself. So I got to get rid of this tangent. Got to get rid of the tangent, right? Got to get rid of that. It's kind of like if I was solving, if I said, you don't need to write this down, but if I said 2x equals 6, and I need to solve for x, I need to get rid of the 2. Well, the 2 is multiplying. I do the opposite of multiplying 2. I divide by 2, and that makes the 2 go away, right? Well, to get rid of this tan, I do the opposite of tan. What's the opposite of tan? Opposite of tan is inverse tan. That's going to cancel that out. But whatever I do on the left, just like I divided by 2 on the left, I divide by 2 on the right, I got an inverse tan on the right. So that's going to make my angle, this cancels out, theta equal to inverse tan, comma, -1. And so just get the inverse tan of -1 on your calculator. And what that's going to be is, it's actually going to be -45 degrees because it's over here. So anyway, but or 45 degrees, but it'll end up being -45. So it's be -45 degrees because it's on the opposite side. But that's neither here nor there because that's not what we want to figure out. By the way, let's convert that into radians, and we can do pi over 180 degrees. Okay. So that's going to be equal to -45 degrees pi over 180 degrees. And then both are divisible by 45, right? To simplify it. And it's going to be -pi over 4. Okay, because we want our answer in radians. So here we have our angle is -pi over 4. But that's not what we want, right? So we have here -pi over 4. I'm going to do it on my little, can you guys see this here? So this angle is pi over 4 is the green. But the whole orange, what is it all the way from here to here that we want to subtract? What is that angle measurement? Let me just call someone at random. What is that angle measurement? Let's go with Eric. The orange, what angle measurement is that? All the way from here to here for the orange.
180 degrees.
Okay, how about in pi?
It's pi.
It's pi. That's it. In pi, it's just pi. So it's going to be pi minus pi over 4 will give me this angle right here, which is the one that we want. So pi, let's make this a denominator of 4. It's 4 pi over 4 minus pi is going to be equal to 4 pi, take away 1 pi is 3 pi over 4. That is 3 pi over 4 for this angle right here. 3 pi over 4, and that's the angle I want to use. So from here to here is 3 pi over 4. Now, with all that, you can also use your unit circle to figure out the... Wait, are there any questions? Because I feel like I gave you a lot of information at once. Whoa, what the heck just happened there? Are there any questions? Okay. Another way we can look at it, if you'd like, is you found that angle, we solved pi, we solved it, we got -40, we got -45 degrees. Let me hide this thing here. We got -45 degrees, and we got -pi over 4. What you can do is you can say, hey, man, pi over 4 right? We want the pi over 4 over here. But we know pi over 4 is this over here, right? You see it? It's 45 degrees. Pi over 4 is right here. So it's 1, 2 of these angles, right? So let's go on this side, 2 angles. 1, 2. There's my pi over 4, or my 45 degrees. How many degrees is that? Or how many radians? It's 3 pi over 4. You can find it, just do that on the unit circle. Just figure out where it is over here and then find the same distance here and just say, oh, the unit circle is 3 pi over 4. You can do that because the unit circle actually goes in the counterclockwise direction, 3 pi over 4. Anyway, after all that, we still have to solve for the radius, which is this right here. Solve for the radius, okay? And that is the more simpler part. We do a squared plus b squared equals r squared. A squared plus b squared equals r squared. 3 root 2 squared plus negative 3 root 2 squared plus 3 root 2 squared equals r squared. Okay. You guys good? So negative 3 root 2 squared. I guess I don't know if I should. Oh, you guys already solved it. But I guess we should say negative 3 root 2 squared is what? What is that? Well, remember, a negative times a negative is a positive, right? So negative 3 times negative 3 is positive 9. Root 2 times root 2 is just 2, right? They just cancel out. Plus 3 times 3 is 9 times root 2 is 2. And then that's going to equal r squared, which is 9 plus 2. 9 times 2 is 18 plus 18 equals r squared. 18 plus is 36 equals r squared, right? 18 plus 18 is 36. 6 square root of 8, square root of 36, r equals 6. So we have r equals 6. Is that too fast? Pythagorean theorem. So, final answer, if you remember, right? If you remember that the polar form is the radius and theta. I have my radius of 6 and my theta of 3 pi over 4. And that's your answer, which is what you guys got. 6 comma 3 pi over 4. I have one more to do. Was I presenting that? I think yeah, I am. I'm presenting. Okay. Thank you. Are there any questions? It's the hardest part. I think that's the hardest one. But you got to just use your intuition. If you draw the pictures, you can figure it out. And then practice on delta math. You know, you can practice those on delta math. Okay, one more. This one's a little bit easier. So here you go. 6, 3 pi over 4. There's the answer. You guys see that? Are you guys on the pair deck with me or no? I'm on the pair deck now. I guess I should present the pair deck. Okay. So, oh, here's the next one. Rectangle. This one's a lot easier. A lot easier. Ha ha ha. If you draw the picture. So 0, comma 3 root 3. Go ahead and write that. That's in rectangular form. Go ahead and write it in polar form. Do it. Do it now. Do it now. You got it. You guys are working on that thing. Let's see. We're having people. I cannot see you, Jay. Are you there, Jay? Are you skipping class?
No, I'm here.
Okay, turn your camera on. Okay, Isaac. Are you there, Isaac? You got your fake camera on. Gracie, why is everyone turning their cameras off? You haven't. Thank you, Ariana. Okay. Are we traumatized by the Lucas incident? I hope you're okay. Grace, is that why your camera's off? Because you're traumatized by Lucas? Okay. Jose, are you there? Jose! I think Jose is not here. Okay. Oh, Jose says be right back in like 1 minute. Okay, Jose, I got you. BRB means be right back. And Jose is back. Welcome back, Jose. Okay, I'm going to check out your answers. See what you guys got. You guys want to check them out with me? Actually, I'm going to look. This one's much easier. At first, you might say, oh my gosh, this is super hard. But, well, let's see what you guys got. Yes. Oh, very good. Okay. Yes. The first 3 people I saw are getting it right. Yes. Ooh. How'd you get that design in there? What the heck? That's crazy. Whoa. Why are you doing that? That's crazy. Okay. Woo! Okay, let's take a look at the answers. Yes. Okay, I have to present. Present now. Wait, tomorrow Friday? You guys ready for that test? Tomorrow's Friday, so we have the late start or something like that. All right. Here we go. What do we got? 3 root 3 pi over 2. That is correct. 3 root 3 pi over 2. Correct. 3 root 3 pi over, yes. Yes. No. Whoa. What? Well, I'm totally tripping on this drawing right here. I can't tell if it's 3D or not 3D. Or like, is this in the middle? It looks like it's in the middle, but it looks below. What is? Oh my gosh, I'm like getting a headache. 3 root 3 pi over 2. Whoa! Like this is correct with the question mark, and that looks like a monster. Pi over 2, 3. About to write the answer. 3 root 3. Make sure you know how you got the answer. Whoa, alien. Whoa, happy face. I feel happy. IDK. I don't know what that means. 3 root 3 pi over 2. Oh my gosh. Alien. Okay. 3 root 3 pi over 2. Okay, it's 3 root 3. Oh, this guy looks PO'd. Sideways angry man. It's an angry elf. Angry elf. He's an angry elf. Okay. So let's go ahead and here we go. 3 root 3 zeros. Okay, so again, I would recommend drawing a picture. Drawing a picture. Let's see where this would be at. Draw my coordinate plane. Okay. Okay, so 3 root, go x is 0, y is 3 root 3. That means up here, we go 3 root 3. And you can see this is the radius. It shows you the length of the radius right there. It's just there. So that's pretty straightforward. So we got the radius of 3. Hang on. The radius of 3 root 3. Now, what is my angle measure? Well, what the heck? We can calculate it out. However, I can see, I mean, I guess we should calculate out just for fun of it. But you can look on your unit circle that this is pi over 2. The 90 degrees. So 3 root 3, is that too fast? Pi over 2. Of course, we could solve for the pi over 2 if we go, how do we do this? It'll be tan theta equals opposite over adjacent. I think we're going to go, you can do the y. I think it's 3 root 3 over 0. Would that work? I think that might come out to be, I'm not sure how you would enter that. Where's I don't have my what is my calculator, my cell phone calculator. I think it's 3. I'm trying to think of it because it's y over x. So, shift tan 3 times 3 times root 3. Trying to figure out how to, I need my regular calculator. Actually, it's 3 times root 3, close parentheses, all over 2, close parentheses. Will it work? Oh, because I'm in radians. I don't change it out of radians, but you can put it in your calculator. I'll have to get my, if you guys want me to show you how to get my calculator downstairs. Other than that, you can look on the unit circle. So if you want me to show you how to do that on the calculator, you can, I can show you when we go downstairs. All right. I can show you after class. But that's pretty much it for the lesson. Okay. So remember, test is tomorrow, so do a couple more of those problems for the test, right? Do a couple more of those problems. Remember, class doesn't end until like 1:55 or something. So why don't you use that time to study your math for another 45 minutes and you can get an A on that test. When's the last day to turn in homework? Kayla, when's the last day to turn in homework? Any late stuff or anything?
The 11th.
Yeah, was that Monday? You said the answer. I don't even know the question. Yes, the 11th. That's right. Very good. Monday. That's the last day turn. So anything after that, I'm not bringing your grade up. So get it. Don't be, oh, sensei, I don't, right? You do it now. Do it now. Get it done now. And let me know if you've turned it in and stuff like that. Okay? Are there any questions? How many of you already, I'm just curious, how many of you have already typed bye sensei in the chat and are ready to slam it so you can get out of there, right? See, Matthew already has this. Look at this. Everyone already had, they're all like just itching to hit bye sensei. So you're just like ready, just want to slam it like that. Slam it. Okay, get out of here, guys. I'll see you tomorrow. See you tomorrow. Bye, Brandon. Bye, Taylor. Bye, Joshua. Bye, Ishi. Bye, Natalia. Bye, Annika. Bye, Roberto. Bye, John. Bye, Eric. Bye, Jacob. All right, I have Kayla and Jasmine. Jasmine, I can see your face. That's awesome. Okay, what's up, Jasmine?
So I've been kind of confused on how to solve for theta. I know how to solve for r, but I don't know how to solve for theta.
All right. Let's do another problem, okay? Oh, you froze. No crying. Okay, I can hear you now. I think you're unfrozen. Hang on, I'm looking up a problem here. That's why I'm frozen. It's just drawing the triangle and getting the tangent, using the tangent.
I understood that part, like with the division and all that. I just didn't understand the part where you transferred it from the tangent to the degree. I didn't understand.
You mean to the radians?
Yeah. Yeah, that.
Let me try to find a good problem here. Still looking for a good problem. Wait, you want to just, so you know how to get it, you just know how to change it to radians? That's the only thing?
Yeah.
Or do you want me to try to get it too, or?
Both, kind of, because I'm kind of barely understanding how to get it, and then the radians it just confuses me.
Okay, I'll do the whole thing then.
Okay.
Does that sound good, or does that sound like what you'd like? Okay.
Yeah.
3 comma negative 3 root 3. Okay. Okay, we're going to do this one. 3 negative 3 root 3. Okay, if you're taking the test right now, what's the first thing you're going to do?
Draw out the triangle, or
Yeah,
graph
just
it.
draw it out.
Yeah.
So I'm going to draw it. I'm going to draw it pretty big. So 3x, y. So I go over 3, and I go down 3 root 3. So it's somewhere around here. It doesn't need to be exact, right? It's right there. Got it?
Yeah. Are you supposed to be presenting?
I am supposed to be, am I not?
No.
Sorry. Okay. All right, how does it look?
Okay.
Oh, did someone just join the class?
No, that was
me presenting, I think. Okay. All right. So, right, I have 3 negative 3 root 3. So that means I go over 3, whatever that is, and I go down negative 3 root 3. So I get this point right there, right?
Yeah.
Okay, so let's draw it. Now, from that, oh, it's terrible. From that, I can create a, I don't like that. Let me start over. Don't like that. It's going to bug me. 3 comma negative 3 root 3. Redrawing it. Okay, so I go right about here. Okay, so now, so there's my line. But let's see, how would you draw the triangle? Where would you put the next line? From where to where? I don't know if you could, it's a weird thing to ask, but I just want to see if you know how I would, that's the important thing. Where would you draw the, where would I draw the line to? From this point to where?
To
Up, down, left, or right?
the left.
No.
Up.
Yes, up. Because you see it as it's spinning around here like this, right? So you want to
Yeah.
see angle here. If I drew it here, well, oh, that might work, actually. But you would have to go, but you wouldn't know the length. I guess you could do that. You could do that, but I'm gonna draw it up here. And that way my angle is going to be right here. Usually you want to draw it to the x-axis. Okay? And draw the triangle to the x-axis, not to the y-axis. Now this is not, because my calculator is only, if I use my calculator, it is only able to solve for the angle in the triangle. But that's not the angle that I want. Do you know what the angles that I want?
The angle around the triangle.
Yeah, so we're going to start here. It's actually going to go all the way around here. This is the, it always starts on the x-axis and goes to that line. That's the angle that we want.
Okay.
Okay, so you with me?
Yeah.
But we're going to solve for this one. We have to figure out this one because our calculator only allows us to do this. Now we can use a unit circle to figure out this one actually, and we'll go over that if we can figure that out. But let's go ahead and solve for this angle right here though first. The green angle, right?
Right.
So what's the length of this right here?
It would be negative 3 root 3.
Yeah. And what's the length of this one here?
3.
3. So let's set up our equation. Tan theta equals what?
Negative 3 root 3 over 3.
Negative 3 root 3 over 3. So let's make this simpler. If we reduce it, it'll be a lot easier. So let's go, first let's get, well, I'm going to reduce this tan theta. Can I simplify this? Negative 3 root 3 over 3?
Yes.
To what?
To root 3? Really?
Yes. Well, those going to cancel, but don't forget the negative there. So let's say negative root 3. Okay, so now I want to get my inverse tan. Get rid of that tangent. And then I do the inverse tan here. So I get the inverse tan of negative square root 3. I need to get my calculator to get it.
Okay.
So I'll be right back. I'll be like 30 seconds.
All right.
Yeah. Almost do like literature stuff lately. You got message from a like What? Actually, I'm in class right now. Well, hang on. I'll tell you in a bit. Okay. All right. Sorry about that. You still there?
Yeah.
Okay, so I got my calculator because I had it downstairs. Okay, so I want to get let me simplify this. So this is going to cancel out, right? The negative tan and the tan. So it's going to be theta is equal to the inverse tan times negative root 3. Right?
Right.
So in the calculator, make sure you're in your degrees. Inverse. Do you have a calculator that you're using, I hope?
I have one, but I don't know where I left it.
Okay. Well, I mean, when you take the test, you're going to need it. Or I can show you how to do it on the unit circle too. Okay. So negative square root 3 and we get negative 60 degrees. So this is negative 60 degrees. Are you with me so far?
Yeah.
Okay. Now, let's go ahead and do this. So you don't have to calculate it. We want to figure out the blue angle. Or not, I'm sorry, the purple, this one right here. This is what I mean by the purple angle, right? So the way I could do that is, let's see, I'm trying to find a different color. Is watch this. See, I have my orange. I can go all the way around to here. All the way around. How many degrees is that?
It's 300, I think.
All the way around?
Yeah.
I feel like someone just entered. Did someone enter the class? No, I heard a ding.
Oh, 360.
360 is all the way around, right?
Yeah.
So if this is 360 and this angle's 60, how can I figure out the purple here?
You subtract.
Yep. So I'm going to go 360 minus my 60, and I will get my purple angle, which is 300 degrees. Does that look like it would be 300 degrees to you? Did I lose you, Jasmine?
Can you hear me?
I hear you now.
Okay.
Did I lose you for a second?
Yeah, my Wi-Fi is...
Okay. So did you hear my question?
No.
Okay. Do you understand? I did 360 minus 60. Did you get that part?
Yeah.
That makes sense to you?
Yeah.
Okay. And that gives me 300 degrees.
Right.
My question was, does this look like 300 degrees all the way from here to you?
Yeah.
Yeah. I mean, this is 360 all the way around, so that's probably about 300 degrees.
Yeah.
Now, you want to change that to radians. That was your question, right? So you can convert it, or what you can do is you can look at your unit circle here. Look at my unit circle. See the unit circle?
Yeah.
Do you have one of these? Hang on.
No, I use the one on the
On the canvas?
Yeah.
Great. That's fine. How many radians is 300 degrees? Looking at my little unit circle there.
Is it 5 pi over 3?
That's correct. So it's right there on the unit circle. So then it's going to be 5 pi over 3 radians. And that's how you figure it out.
Okay.
Now, you said you know how to do the radius already, right? So you don't need me to do that, or I could do it if you want.
No.
Okay. So I don't know. I think the best way to do that on the calculator. The other way you could do it if you don't have a calculator, it's a little bit makes your brain kind of work a little bit harder. But remember, we said that like to figure out where this angle is, the angle measurement. Actually, do you have a calculator? I think it'd be easier if you had a calculator.
I don't know.
You don't have to do it now, but when you take the test, do you have access to a calculator?
Yeah, I'll have access to a calculator.
Okay, perfect. So use the calculator to find it. You can also figure this out that it's 300 degrees by going to find this. The tangent is sine over cosine.
Okay.
So you have to figure out which one would be negative. So if I go this over this, I'd get this is sine, right?
Right.
Y is sine. This is cosine. So you want it to be equal. You want your angle measure to equal negative root 3. And you try to figure out, well, I see a negative root 3 right here in here. Let's see if it ends up being negative root 3. So you go this divided by that and see if you get negative root 3. So I go, right? And let's see. Can you see both of them?
Yeah.
I go negative root 3 over 2 divided by 1/2. Okay. And then that's like saying negative root 3 over 2 times you flip this 2 over 1, right? This is equal to this, multiplying it by the reciprocal. And then you can see the 2's cancel out and ends up being negative root 3 over 1, which is negative root 3. And then you say, oh, that's where my angle's got to be, right? You just kind of have to, like, if you don't know, you just divide everything, right? You say, oh, it's this one right here. And they say, oh, look, it's 5 pi over 3. You can figure out your angle by that. But you have to divide these to make sure it equals this right here.
Okay.
So you might have to try dividing this. Like if I thought, let me try this one. I see root 3, so it's sine over cosine. You have to do sine over cosine. If I did negative 1/2 divided by root 3 over 2, trying to show my spacing. Negative 1/2 divided by root 3 over 2 would be negative 1/2 times 2 over root 3. Well, it's not going to be that because that's negative 1 over root 3. That's not it. So you have to figure it out that way. Or just use the calculator. I think the calculator would be easier, and then you just figure out. Anyway, you have to practice it, though.
Okay.
How's that? Did that help, or did I?
Yeah, that helps.
Okay, good.
Okay.
All right. Do you have any other questions?
No, that's it.
All right, cool.
Okay. Thank you.
Well, then tomorrow.
All right.
Okay, I'll see you later.
All right. Bye, Sensei.
All right, bye.